Welcome to the wonderful world of causal loop diagrams. Today we'll be exploring how these diagrams can help us understand and analyze complex systems. By the end of this lecture, you'll be able to draw causal loop diagrams like a pro, and you'll have a newfound appreciation for the power of visual representation in solving complex problems. First things first, what exactly is a causal loop diagram? Simply put, it's a visual representation of a complex system, showing the relationships between variables and the feedback loops that drive the behavior of the system. Think of it like a map of the interdependent relationships between different components of a system. Now, let's talk about the components of causal loop diagrams. Variables, relationships, reinforcing and balancing loops, and feedback loops are the building blocks of these diagrams. Let's take a closer look at each one. Variables are the entities that we are interested in tracking in a system. Relationships are the connections between variables, which can be either positive or negative. Reinforcing loops are the pathways in which changes in a variable lead to further changes in the same direction, whereas balancing loops are the pathways in which changes in a variable lead to counteractive changes in another variable. Finally, feedback loops describe the circular causality that drives the behavior of a complex system. Next up, we'll discuss constructing causal loop diagrams. It's important to first understand the system that you want to represent, identify key variables, and establish the relationships between these variables. From there, it's simply a matter of putting it all together in a clear and accurate representation. This process may seem overwhelming, but with a bit of practice, you'll be constructing causal loop diagrams like a boss. Once you've got your causal loop diagram, it's time to analyze it. This is where the real magic happens. By simulating the behavior of the system over time, we can understand the dynamics of the system and make predictions about its behavior. This is crucial in helping us understand and solve real-world problems. Finally, we'll talk about the applications of causal loop diagrams. These diagrams can be used in a variety of fields, including economics, politics, and environmental science. They provide us with a visual representation of complex systems, allowing us to make informed decisions and promote positive change in the world. In conclusion, causal loop diagrams are an incredibly powerful tool for understanding and analyzing complex systems. With the knowledge you've gained from this lecture, you'll be able to construct and analyze these diagrams with ease, and you'll understand the importance of visual representation in solving complex problems. So go forth, use your newfound knowledge for good, and never be intimidated by a complex system again.